Okay, this is part B, using logarithms to solve equations. So we use logs when we cannot get common bases, like we did in some previous problems. So if I cannot get common bases, I'll need to know how to use logs. Let's start with just rewriting. So here I have an exponential equation that I want to write in log form. So I first identify the base. The base of my exponent is 3. So when I write the log, the base of my log should stay the same. The base goes a little bit below. And then the argument means we're going to switch the other two pieces. So log base 3 of 81 equals the exponent from before. And that's it. We're just switching forms. Keep the base, switch the other two pieces. Rewriting a log and exponential, same idea. I want to identify the base. The base is 7, so the base of my exponent should be 7. Switch the other two pieces. So 7 to the negative third equals 1 over 343. Okay. Okay, now we have a bunch of examples of solving some different equations. So just some simple log equations to start. Log base 7 of 19 equals x. So the variable is already by itself. This is basically practicing how to type it into your calculator. We'll use the change of base form to do that. So remember, the base goes on the bottom of our fraction. So we'll write log of 19 over log of 7 equals x. Common mistake here is when people type it into their calculator, they forget to close the parentheses. So I'm going to type log button's down here by the 7. So log of 19, close parentheses, divided by log of 7, close parentheses. 1.513 equals x. Okay. The next one I have here, the variable is within the log. So in order to solve for the variable within the log, I want to switch forms. Essentially, whenever you're stuck, you're like, I don't know what to do next, switch forms. So we're going to switch this log to an exponential. Identify the base. Base is x. So base stays as x. Switch the other two pieces. X to the 5th power equals 32. Now here's just basically a little bit of guess and check to figure out what will work. So I'm trying to raise something to the 5th power and get 32. If I raise like 3 to the 5th, that's too big. So if I raise 2 to the 5th, oh, that works. So I know my answer. X equals 2. Again, I have another log that's written with the variable all by itself. So you have a couple options. You could type it into your calculator. So log of 1 over 64 over log of 4, and that would absolutely work. We could look at this by switching forms as well. So this is option 2, so or base of 4 to the x power equals 1 over 64. Now I know that if I have a fraction answer, I'm going to have a negative exponent. So I can think of this as 1 over 4 to the negative x equals 1 over 64. Well, I know that 4 to the 3rd equals 64. So 4 to the negative 3rd would equal 1 over 64. So x equals negative 3. Next problem, again, I have a log, so I could use my change of base, but let's see what happens when we switch forms here. 9 to the x power equals 1. Base of 9 to the x equals 1. Now I know that anything raised to the 0 power equals 1, so x has to be 0. Okay, our last sets of problems here, we're actually solving some equations. So I have a little bit more going on with my log in part E. I want to get the log all by itself. So I need to get rid of this 4. Right now the 4 is being multiplied, so I'm going to divide by 4 to undo it, leaving me with log of 2x equals 20 divided by 4, which is 5. Now notice there's no base here in this log. So we've talked about before, if there's no base in the log, that means your base is 10. You have a hidden base of 10. So if I want to solve this, now that the log is all by itself, I'm going to switch forms. So I'm going to keep my base of 10, raised to the 5th power equals, the argument equals 2x. Switch the other two pieces. Now, this is something I can actually calculate. I can do 10 to the 5th. That means I have 1 with 5 zeros equals 2x, or type it in your calculator. To get x by itself, I just divide by 2, leaving me with 50,000 equal 2x. Okay, so big idea, get log by itself and then switch forms. Here's where I switch forms. Part F. So I'm solving for a missing exponent. Okay, the base and the exponent are already alone, so I'm just going to switch forms right away. Log of the base of 3 of 17 equals b. So keep the base, switch the other two pieces. Now I can type that in my calculator. Base goes on the bottom. And when I type that into my calculator, I get 2.579 equals b. Last two problems here. This is very similar to one we just did, so I'll switch forms to figure out my missing exponent. Log of the base, so log of 20 of 56, log base 20 of 56 equals r. Type in my calculator. Base goes on the bottom. Use parentheses. 1.3437 for r. And then lastly, I have an exponential equation, but it's a little more complicated than the one I just did, right? So I still have a missing exponent, but it has a whole bunch of other stuff happening. So big idea here, you want to get the base with its exponent alone. So that means this guy needs to be by itself, and then I'm going to switch forms. So first I have to get rid of the plus 3. I'll get rid of that by subtracting by 3 on both sides. So now I have 9 to the n plus 10 power, 81 minus 3, 78. Now that the base with its exponent is alone, I can switch forms. So log the base of 9 of 78 equals n plus 10. Okay, when you switch forms, you should have the variable on the other side of the log. That's how you know you're doing it right. Type this in my calculator. Type that in, I got 1.983 equals n plus 10. So we will finish by subtracting 10 on both sides to get negative 8.017 equals n.